Hello friends, I welcome you all on India's largest live learning educational platform, that is Gradeup. All the candidates who are joining me, just quickly confirm whether my audio and visual quality everything is clear. Everybody just please confirm whether my audio and visual quality everything is clear so that we can proceed. Now till you report me this, let me just brief you about the session, what we are going to achieve in this particular session. And let me just brief you about the series also. You all must be aware that in this series of sessions, daily 9 p.m. in the evening, we are discussing the crux of important topics as part of your revision for coming GATE 2021 examination. We all know that very less time is remaining. Hi Bhargav, how are you? Welcome to the session. For the coming GATE examination, very less time is remaining. So you may not be having that much flexibility to revise your subject. So we are coming up with small sessions where we discuss the important crux of the topics which are most probably going to be asked in the coming GATE examination. In this regard, today we are going to discuss auto transformer and three-phase transformer for your subject electrical machines. Already we have completed almost 10 lectures in this series of sessions, and today we are going to have 11th lecture. I hope some of you must have followed those sessions and you must have got some value addition out of these sessions. And if you have not followed this session, you can go to the Gradeup Gate channel, YouTube channel, and you can see the playlist. All the sessions are available and you can go through them, and definitely some value addition, some positive intake you will definitely get. Now without wasting much time, some of you may be joining me for the first time. So there is a brief introduction about myself. My name is Ashutosh. 10 plus years of teaching experience, completed MTech from IIT BYJU'S in 2010. Written a couple of books. Engineering Ethics 2019 edition is already in market. If you are preparing for engineering services, you must have gone through this book. A sample copy of this book is already available on internet. If you write Engineering Ethics 2019 by Ashutosh Sir, you will get a sample copy link. You can read that. Power System 900 plus page book is yet to hit the market, and I am trying my level best that the next coming year it is going to be public. My areas of expertise are power system, electrical machines, electromagnetic field theory, material science, and obviously engineering. Now friends, before I start the session, I want to wish you all of you a very happy new year 2021. 2020 is about to go in a couple of hours, and I hope that the coming year will bring a lot of success, happiness, health, and prosperity in your life and your family. With these words, I want to welcome you all on the New Year virtual party on 1st of January 2021, 7 p.m. only on Gradeup, and with the theme "Hum honge kamyab with Gradeup." So book your slot and do not forget to join me in further sessions. Now friends, let us talk about the auto transformer. When I say auto transformer, what is the first thing which is going to strike your mind? Tell me. What is the first thing which is going to strike your mind if you say auto transformer? That is a common winding is used for both primary and secondary terminal. What is the convention of saying primary and secondary terminal? Primary side we are going to connect the source generally, and secondary side we are going to connect the load. In case of auto transformer, we are using just one single winding, a common winding for both primary and secondary terminal. This is the most unique feature of auto transformer, which makes it different from a two-winding transformer. For example, suppose this is your common winding. Please focus. Suppose this is the supply terminal or primary side, and this is the load terminal or the secondary side. You know that EMF per turn for a given transformer is going to be constant. You know that. So more number of turns means more voltage or high voltage. It means this side you are having the high voltage terminal, and obviously the current is also going to be IH. This side you are going to have the low voltage terminal, and obviously the current is also going to be IL. How we are making the connections, this is very important. Here we are going to connect the load as per our requirement, and this side we are going to connect a source. Let me hide my beautiful picture so that you can see the content on the screen. This is your AC source. Okay, now you please try to understand, whatever type of transformer you are having, for any transformer the input power and output powers are going to be same. Why? Because transformer is a static device, it is not a rotating machine. Losses are going to be very less, core losses and copper losses. So you can understand input and output power is about to be same. It means, can I write VHIH is equal to VLIL? Can I write this equation with due respect to the losses? Tell me yes or no. Can I write this? At least say yes or no. Now, if you are saying that VH is more than VL, then automatically you can deduce that IH is going to be less than IL. It means the current at the high voltage terminal is going to be less than the current at the low voltage terminal. What does it mean? What does it signify? If you see the current in this part of the winding, suppose this is A, this is B, and this is C. If you see the current in the AV section of the winding, this is going to be the same current which is coming from here, and this is going to be IH. Now you know this current IH is less than this current IL. It means some current must be coming from this side in this direction, and this current is going to be IL minus IH. Now for any terminal, whether it is primary or secondary, whatever current is coming, that must be going. Whatever current is going, that must be coming. So if the going current is IL, the incoming current is also going to be IL. If the incoming current is IH, then the outgoing current must be IH. This is how you are going to make the connections, and you are going to write the voltages and currents for an auto transformer. If you see the number of turns, obviously you can see the number of turns at the high voltage side are going to be NH, and the number of turns at the low voltage side, they are going to be NL. Now I'm going to discuss a very important phenomena in auto transformer. I want all of you to give me 100% concentration. Only one candidate is answering, no problem with that, because I just want top 3 ranks. Okay, first, second and third, if I get 3 ranks, I have 4 candidates in my class, so definitely I'm going to get top 3 ranks, and I'm satisfied with that. I satisfy very easily. Now I want to write the MMF balance equation for this auto transformer, because at the end of the day it is a transformer. If it is a transformer, definitely it is going to have some power being transferred inductively. What is the major difference between a transformer, 2-winding transformer, and auto transformer? In the 2-winding transformer, the 2 circuits are electrically isolated. 2 circuits are electrically isolated. So whatever power is being transferred from the primary circuit to the secondary circuit, this is the inductively transformed power. Inductively transformed power. But when you see the auto transformer, there is a direct connection between the primary and secondary side if you take this type of circuit construction. And because of this direct connection, if the total power transformed by the auto transformer is S auto, then it is going to be made of two parts, inductively transformed power and conductively transformed power. Conductively transformed power is because of the direct connection between the two terminals, and inductively transformed power is because of the transformer action. If you have read the basic construction and working principle of transformer, you must be knowing what is transformer action. Can you tell me what is transformer action? In the most simple language, you can say the transformer action is that you are connecting load in one circuit and you are supplying current or power to that load by connecting a source in the other circuit. Yes or no? Primary side you are connecting the source, secondary side you are connecting the load. It means two different circuits are used to transform the power from the source to the load. Now, in case of auto transformer, how you are going to decide what is inductively transformed power and conductively transformed power, you have to understand the MMF balance. Now, you tell me, if I am saying the auto transformer is on no load in the starting. Suppose in the starting, the auto transformer is on no load. What is the current taken from the supply? I naught. No load current taken from the supply. In this case, can you tell me what is the current going to the load? Can you tell me what is the current going to the load? Because this is the no load condition. So definitely there is no current taken by the load. There is no current taken by the load. So IL is going to be 0. And whatever current is taken by the primary is simply going to be I naught. That is the no load current taken by the auto transformer. Now what is the purpose? If no load is connected and transformer is a static device, can you tell me what is the purpose of this no load current? What you are going to do with this no load current? NHI naught. NHI naught. This is the MMF which is going to establish flux in the auto transformer, which is the first phenomenon. Hardik Agrawat, I understand your emotions, but don't get emotional. Okay, I want only 3 ranks in the final gate result, that is first, second, third. Nobody remembers who is fourth. Anyways, this is not my overconfidence. This is my belief on my students. Anyways, let us focus. Now suppose you are putting the transformer on load. Now suppose you are putting the transformer on load. What is going to happen? You tell me. The moment you connect any load to the secondary side or the low voltage side, what is going to happen? You tell me. Some current is going to flow. IL is not going to be 0. It means whatever current is going to flow in the BC section of the winding, some current is going to flow, and this current is going to generate some MMF NLIL, and this MMF is going to oppose the flux in the core. But this cannot reduce the flux in the core. Why? Because you cannot decide things in your life which you cannot change. Sorry, you cannot change things in your life which you don't decide. You can only change things in your life which you can decide. Who is deciding the flux? Flux is being decided by the supply connected to the primary side. So until and unless supply is going to be changed, how you are going to change the flux? It means flux is not going to change. Instead, to neutralize this MMF, extra current is taken from the supply. Extra current is taken from the supply. So the current is going to increase from I naught to some higher value depending upon the load you have connected. See, these MMFs are not exactly NLIL. This is not exactly NLIL. I am just making a reference out of here. It means if you see your auto transformer, this is A section, this is B section, and this is C section. You tell me in which parts of the winding or the sections transformer action is going to happen. You tell me. The MMF of AB section of the winding must balance the MMF of BC section of the winding. The transformer action is going to happen between AB and BC section of the winding, neglecting the I naught, that is the no load component of the current. Why I naught I am neglecting? Because I naught is going to be just 2 to 5% of the rated current. So I am able to neglect it. This thing is very, very important to understand how you are establishing the MMF balance equation, because this will only tell you how you are going to compare your auto transformer with the two winding transformer. Now you just close your eyes and directly you can write what is the MMF for AB section of the winding. What is the number of turns? NH minus NL. What is the current? IH. What is the MMF for BC section? Number of turns NL. What is the current? IL minus IH. Just expand it. NHIH is equal to, NHIH minus NLIH is equal to NLIL minus NLIH. NLIH will cancel out and you can write NHIH is equal to NLIL. Everybody just tell me, are you getting this idea clear in your mind? Hardik, what is your doubt? Which value is less? Okay, you are saying this 2 to 5% I naught is a lesser value. Yes, you can say that. You can say that because it is auto transformer. Are you getting this? Now, if you have this equation, can I write VH upon VL as NH upon NL, and this I am deciding as auto transformer turns ratio. This I am deciding as turns ratio of auto transformer. You always remember that if you want to use the formulas in solving the problems in the real examination, do not forget to miss this information. This is very, very important, that always you will write the auto transformer turns ratio as the high voltage number of turns divided by low voltage number of turns. Similarly, you can write IH upon IL as NL upon NH by the MMF balance equation, and you can write it as A auto transformer. Second important equation. Is it clear to all of you? I will take some questions also, don't worry. Now, but one question is remaining. Why we are using the auto transformer? Why we are so much interested in the auto transformer? Why auto transformer? What is the reason? Listen very, very carefully. If you say for the same kVA rating, if you compare the two winding transformer with the auto transformer, definitely auto transformer is using the single winding. So definitely the leakage flux is going to be less. The leakage flux is going to be less in case of auto transformer because just one single winding, common winding you are using for the primary and secondary circuit. If leakage flux is going to be less, the reactance which represents these voltage drop due to leakage flux is also going to be less. So voltage regulation is going to be less. It means if you are using the auto transformer, you are going to get a lesser voltage regulation. This is the first thing. Are you getting this idea clear in your mind? Second, because you are using just one single winding instead of two windings, so definitely there is going to be some copper saving. What is the meaning of copper saving? I want to ask you. If you go to a shop and you want to buy some copper, so what you will say? You will say the weight of the copper. Yes or no? Because copper is going to be a solid thing. So saving or rupees going to be decided by the weight of the copper. How you can write the weight of the copper? Copper weight you can write as copper volume multiplied by copper density. Now copper density is something which is going to be constant for you, for me, and for everyone. It means you can say the copper weight is going to be directly proportional to the copper volume. How you can write the copper volume? If this is your winding, okay, you can understand your winding, if the thickness of the wire is like this, so winding is going to be like this, something like this. Please try to understand my beautiful drawing. So I am interested in this area of cross section. If you know the area of cross section and you know the total length of the winding, which is the length of the conductor or wire used for the winding, then you can write the copper weight being directly proportional to cross-sectional area and the length of the conductor. You know that current you are defining as current density multiplied by area. Current density is again going to be a constant. So you can say current is directly proportional to area, and length of the wire of the winding is going to be directly proportional to the number of turns. So you can write L is going to be directly proportional to N. It means if I want to represent the copper weight, then we can define it as number of turns multiplied by the current. Now number of turns multiplied by the current is nothing but MMF. Yes or no? Now I know that I am using one winding for the auto transformer and two winding for the two winding transformer. So I want to compare the copper weight in case of auto transformer and copper weight in case of two winding transformer. Now you tell me what is going to be the MMF. It is going to be MMF for AB section and MMF for BC section. For equivalent two winding transformer, if you want to write, you can write MMF for AB section and MMF for BC section. How I am going to write the MMF for AB and BC section? This is for auto transformer and this is for two winding transformer. For the auto transformer, you can write for AB section, number of turns are going to be NH minus NL, current is going to be IH, plus number of turns are going to be NL and current is going to be IL minus IH. Now the MMF for AB section for a two winding transformer, for the high voltage side this is going to be NH IH, for the low voltage side or BC it is going to be NLIL. Now from the MMF balance equation you know that NHIH is going to be equal to NLIL. Put it in this equation. Now copper for the auto transformer and copper for the two winding transformer you can relate as. Now if you see NHIH being is equal to NHIH being equal to NLIL, I am going to write here 2 NHIH minus, this is going to be NLIH and NLIH, so it is going to be 2 times NLIH divided by 2 times NHIH. Simplify this, you will get 1 minus NL upon NH. So this is going to be 1 minus 1 upon auto transformer turns ratio. Everybody just tell me, are you able to follow this or not? Now if I want to know the saving, in the copper material, then this is going to be copper saving, copper for the two winding transformer minus copper for the auto transformer divided by copper for the two winding transformer multiplied by 100, you will get the percentage of saving. This is going to be 1 minus copper for the auto transformer divided by copper for the two winding transformer. Now you can put the values from the previous equation and you will get it as 1 upon A auto transformer multiplied by 100 percentage. Now this saving in the copper material tells you, my friend, that you are going to use auto transformer. Auto transformer is best when auto transformer turns ratio is close to 1 and not more than 2. Now you will ask me, sir, why? Now I am saying, let us take A auto transformer is equal to or more than 2. What is going to happen? The saving in the copper material is going to be less than 50%. Are you getting this idea? So saving is not going to be significant. That is the reason we do not use auto transformer and it is better to go for transformer. Are you getting this? This is one reason. Now I want to compare the inductive and conductively transformed power. Suppose I am writing the low voltage side or low voltage terminal power. So this is going to be VL, IL. IL I am writing as IL minus IH plus IH. You can separate it. It is going to be VL, IL minus IH plus VL, IH. Now what is this VL, IL minus IH? Can you observe it from the diagram? Hardik is saying, now I understand why all power transformer are auto transformer. It is not like that, Hardik. Do not confuse yourself and others also. Just see this section of the winding. What is the current IL minus IH? IL minus IH multiplied by VL. What is this? Can you tell me? This is going to be the power being transformed by the BC section of the winding. This is going to be the power being transformed by the BC section of the winding. And you know, BC section of the winding is going to transform the power inductively. Are you getting this? It means this power is going to be inductively transformed. And what is the power which is conductively transformed? The remaining power, VLIH. If you want to know S conductive with respect to the power transformed by the auto transformer, this is going to be VLIH and this is going to be VLIL. VL cancelled, this is going to be IH upon IL, which is going to be NL upon NH, and this is going to be 1 upon A auto transformer. Now you are getting the conductively transformed power 1 upon A auto transformer, that is same as the saving in the copper material. Now you must be getting some idea that why there is a saving in the copper material, because some part of the power which you are transforming is being transformed conductively because of the direct connection possible. If you want to write inductively transformed power, that also you can write. This is going to be 1 minus 1 upon A auto transformer. Everybody just okay with that? Okay, I did it in a little faster speed, but I hope you must have understood the concept. Now if the time remains, then we will discuss three-phase transformer. Otherwise, let us do one question first so that you understand better. See this question on your screen and try to do it. He is saying a 400/100 volts 10 kVA two-winding transformer is reconnected as an auto transformer across a suitable voltage source. The maximum rating of such an arrangement will be. Now some of you FNX Raptor OP, बेटा मैं बिल्कुल ठीक हूं, बट तुम्हारी तबीयत ठीक नहीं है, अपनी तबीयत ठीक रखो. Listen carefully about the question. See, some of you may be thinking, why not use the direct formula? I would suggest you, whenever you are going for the gate examination, try to avoid shortcuts. Otherwise, you are bound to do the mistakes. He is saying there is a two-winding transformer. Let us see what is that. Let us see what is that. It is a two-winding transformer like that. This side he is saying 400 volts. Suppose this side is 100 volts. And suppose this is the dot. And you know, for the transformer action, the dot polarity is, if the one winding current is entering the dot, the other winding the current is going to leave the dot. That is the subtractive polarity you must be having for the proper transformer action. Now, can you tell me what is the current at the high voltage side and current at the low voltage side? Yes. The rating of the transformer is given as 10 kVA. So can you tell me what is the high voltage side rated current? Yes. 10 into 1000, because it is kVA, divided by 400. It is going to be 25 ampere. 25 ampere is going to flow in this direction, dot to no dot. This is no dot and this is dot. If you go to the low voltage side, what is the current at the low voltage side? Rating, losses are very less, so you can assume both input output 10 kVA divided by 100, so you will be getting the current as 100 ampere. Now in this secondary circuit, the current is going to be 100 ampere from no dot to dot. Now I am going to draw. Let me do it here. The auto transformer, and he is asking for the maximum kVA rating. He is asking for the maximum kVA rating. Yes. Suppose This is AB section of the winding and this is CD. Now, you know that if you want the maximum kVA, then definitely you have to go for additive polarity. Additive polarity means both the primary and secondary windings you are going to connect in such a way so that their EMFs or voltages are going to be added together. Suppose first I am keeping AB winding here and CD winding here. This is the dot and it is being connected like this. For the AB section of the winding, what is the current direction? Dot to no dot, 25 ampere. Dot to no dot, 25 ampere. So this is going to be dot to no dot, 25 ampere. For the CD section of the winding, the current is from no dot to dot and 100 ampere. No dot to dot and 100 ampere. It means if you apply the Kirchhoff's current law, definitely in this terminal, the current must be 125 ampere. Suppose you are connecting the load here like this. Suppose you are connecting the load. You are connecting the load here. Then you are going to connect the source this side. You are going to connect the source this side. What is going to be the voltages across these two windings? This winding, the voltage is going to be 400 volt. And this winding, the voltage is going to be 100 volts. It means the total voltage with the additive polarity across the source is going to be 500 volts. And here the voltage is going to be 100 volts. Here the current is going to be 25. Here the current is 125. This is the complete connection. John sin theta, beta, control your emotions. Okay, it happens when it is the last day of year and that year is 2020. It happens. I can understand your emotions, but you should also understand my emotions. Now, you tell me what is going to be the kVA rating. What is going to be the kVA rating? Either you can find it from the source side or from the load side. Multiply the voltage and the current, multiply the voltage and the current, you will get the same thing. You are getting 25 multiplied by 500, or you can say 125 multiplied by 100. So you are getting 12.5 kVA. Now some of you may be thinking that this is the right answer, but my friend, you should always check the turns ratio. What is the turns ratio? Do you remember? High voltage side voltage to the low voltage side voltage. High voltage side voltage is 500, low voltage side voltage is 100. This is going to be 5. Are you going to accept this voltage ratio for the auto transformer? Do you feel that this connection is going to be a good connection? John, what is your name? Sin theta. पागल हो जाओगे एक दिन बेटा. If you are not interested in the session, leave the session. Why you are wasting your precious time and my precious energy? Okay, control your emotions. Do something good in your life. Anyways, it means this connection we have made a mistake because the auto transformer turns ratio we are getting 5. It is not acceptable. It means we have to go for the second additive polarity. Second addition. What is that? Now I am going to keep AB section here and CD section here. Again, in the AB section, you are getting 25 ampere current from dot to no dot, and CD section you are getting no dot to dot 100 ampere. So in this terminal, how much current must be incoming? That must be 125 ampere. It means you are going to connect the source here. Connect the source here, no problem. This terminal, you are going to connect the load. What is the voltage? Here voltage is going to be 400. Here voltage is going to be 100 volts. What is the current here? 100 ampere. And what is the voltage here? It is 500 volts. Now if you see, what is the kVA for this connection? It is going to be 500 multiplied by 100, that is 50 kVA. Or you can write it equal to 400 multiplied by 120. Also you will get the same thing. Input output VA is going to be same for both the sides, primary or secondary. एग्जाम डेटा एंजॉय करो बेटा, एंजॉय करो, ठीक है. Now what is the auto transformer turns ratio? What is the auto transformer turns ratio? It is going to be high voltage side voltage divided by low side voltage. It is going to be 1.25. So it is going to be better, close to 1. It means this connection is going to be the better connection, or actually it is the best connection possible. Now gate, you will be getting these type of confusing answers. If you would have used the first connection, you would be getting the answer 12.5 kVA, but this is the wrong answer. So what is the correct answer? 50 kVA. How many candidates are able to follow me in this? Now we do not have enough time to discuss for the three-phase transformers. We'll discuss it some other day. But I'm giving you one question as part of your homework. Do this question as part of your homework question number 1, and give me the answer to this question in the comment section of this video, whether you are live or you are watching me recorded. I will get the information and I will give you the correct answer. One hint I am giving you: when you write the voltage regulation, you use this equation, E2 minus V2 upon E2. You have to write the voltage regulation with respect to the secondary no load terminal voltage. Okay. The modern terminology, the modern convention is that you represent the voltage regulation with respect to the secondary terminal full load voltage. But in this question, if you follow that, you will not get the answer. Most of the old books, old traditional conventional books, they are still, because they are not changed, they are not updated, they are still using this formula. So you have to use this formula. So this is all from my side for today's lecture. I hope you must have got some idea about the auto transformer. Three-phase transformer we'll discuss some other day. Thank you so much for joining me in this session, but very, very important information for all of you. Now you can interact with your favorite faculties on the Gradeup Telegram group, which is Gradeup_EC and EE discussion. There is a dedicated discussion group for electrical and electronics students, which you can follow to place your doubts. Now, if you are still confused and thinking about how you should go for 2021 or 2022, Gradeup has a very interesting surprise for you. Till 30th of January 2021, you can access Gear Up and Rank Up courses, the classes which are already being taken. In the Gear Up, we have completed theory. In the Rank Up, we have completed question. And if you want to go for Vision 2022, no problem. All this you are going to get under one subscription, that is Gradeup Super. Okay. For any further clarification, you can contact this number. I hope you are going to be assisted positively. These are the star faculties of the electrical department. You must be knowing some of them. All of them are highly experienced and expertise in their field. And this is the result we have produced over the years. 60 plus Gradeup students have secured rank within top 100. You can go to the Gradeup Achievers column. Himanshu Kumar interview I have taken. So it is available. All these. It is not Vision Batch 2, it is Vision Batch 3. See, we have panel of faculties. Sometimes I am taking, sometimes somebody else is taking. So it is not that whosoever is having the slot, every faculty is equally competent. Okay, so don't worry whether I am taking or anybody else is taking. The point is you must get the result. Okay. Now, this is what I was telling you. One Gradeup Super subscription, you will be getting access to all the structured live courses in your exam category, and you will be getting access to the green card so that you can have access to all the online mock tests designed by the toppers based on the latest exam pattern. For any further clarification, you can contact this number. And friends, today, the last day for 2020, let us take a deep breath and say Happy New Year 2021. See, I do not want to give you false hopes for the coming year, because let me tell you that if you want coming 2021 a great year, an important year for your life, then it is you only who can change this. If you have suffered in 2020 or before, if you want your life to get changed, if you want to get selected, if you want to get settled, if you want to simplify things in your life, nobody else can do that. Let me tell you, it is going to be 2021 or 2022. It is only you who can make 2021 a happy new year. So, all my best wishes for your hard work, for your efforts, for your patience, and let us all hope that in the coming year, we means I have already passed out all my examinations, so I'm not worried about that. We means all your friends, colleagues, everybody get whatever they deserve and whatever they aspire. Thank you so much for joining me in this session. A very happy new year to Bhargav, Hardik, and all the notorious students like Exam Data, Johnny, Sin, Theta, great beta, great name, Jairam, Krishna, all the candidates who joined me, FNX, Raptor, Ram Shashi, everyone. Thank you so much for joining me in this session. Take care of yourself. A very happy new year 2021. Practice smart, score better, go greater. Thank you so much.